Today we're going to start Unit 2, which is a review of linear functions. So we'll talk about things like slope, we'll talk about how to graph, we'll talk about not only graphing linear functions, but linear inequalities. So let's start right now with a review of linear functions in general. So what is a linear function? Linear function is a function whose graph is a straight line. Right now we're going to take a look at the notes for Unit 2, Day 1, which is going to be a review of linear functions. Later in the unit we'll get to graphing linear functions, graphing compound linear inequalities and things like that, but right now let's do a quick review of linear functions. So a linear function is a function whose graph is a straight line. And that graph is going to have a constant rate of change, and we call that constant rate of change a slope. And we are going to work on calculating slope today. Let's go ahead and make sure we call our slope m, because that's what we're going to call it in the slope-intercept form, and that's mostly what we're going to be using to graph here. And our slope, another way of saying slope or describing slope, would be rise over run. So we're going to use the formula for slope. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We could also say y sub 1 minus y sub 2, x sub 1 minus x sub 2, as long as we're consistent, but typically it's expressed this way. Now when we're calculating slope using 2 points, I think it's a really good idea to go ahead and label the points. So I'm just going to go ahead, for example 1, and call this x sub 1 and y sub 1, and then I'll call this one x sub 2 and y sub 2. And then what I like to do is I like to just set up my slope, and I'm going to substitute these values in. So I just kind of set up a blank template for calculating my slope. What this does is it helps to preserve my signs if I have any negatives. So let's go ahead and plug in y sub 2, which is 7, x sub 2, which is 9, and then I can do the same over here. Y sub 1 is 3, and x sub 1 is 4. So we'll just go ahead and calculate those values. 7 minus 3 is 4. 9 minus 4 is 5. See if I can reduce it. We want to leave it as a fraction, because that makes it easier to graph. And the slope between these 2 points is 4/5. I'd like you to find the slope between the 2 points for examples 2, 3, and 4. Go ahead and pause the video, and then we can take a look at how you did on those points. Okay, let's take a look at these examples. So example number 2, I should have negative 11/9. Now, depending the order you put your points in, I did x sub 2, x sub 1 on the bottom. I did y sub 2 minus y sub 1 in the numerator. Had you flip-flop all those orders, your negative sign would just be in a different place, but it should still be negative 11/9. Moving over to example 3, negative 5 is the slope. When we graph, you might want to leave it as negative 5/1 just to remind me that that's what the rise over run should look like. And then for example 4, I have negative 2/3. So on the next page we have our special cases for slopes. So go ahead and calculate the values for the slope between the points given in example 5 and example 6. So looking at example 5 here, I have 5 minus 5 over negative 11 minus 3. I end up with a 0 in the numerator. Any number divided by any 0 divided by any number, any non-zero number, is going to be 0. So I have a slope of 0, which is just fine. That's going to be a horizontal line, so it has no slope. Example number 6, you're going to see that I end up with negative 1 minus negative 1 in the denominator, sorry. And that would put a 0 on the bottom. We can't divide by 0, so we say that slope is undefined. And that really, when we see what that looks like on the graph, you're going to see that that's a vertical line. So all we've looked at here with examples 5 and 6 are kind of our 2 special cases that calculate the slope of a horizontal and a vertical line. Now we're going to look at the types of slope. So we could have a positive slope, which is going to grow up and to the right. Another way to look at that is not only does it grow up and to the right, but you could view this as growing down and to the left. Either way, if we read this slope left to right, it appears to be growing, so that is a positive slope. On the other hand, if we go down to a negative slope, if you read it right to left or left to right, that is going to be a downhill slope. So that is going to be moving down and to the right or up and to the left. Now we'll get into our two special cases. So a slope of 0, that doesn't have any rise, so that slope is just going to be a horizontal line. And we're going to describe that. We're going to use an acronym. We're going to call, when we describe our horizontal and vertical lines, we're going to use the acronym HOI-VUX. So let's first talk about what HOI is, because that deals with horizontal lines. So HOY is HOI. The H stands for horizontal. The O is really a 0, and that stands for a slope of 0. And the Y stands in for Y equals, which is the equation of a horizontal line. When our slope is undefined, what we're really looking at is a vertical line, and we do have the other part of the acronym VUX to describe that. There's a graph of our our vertical line, and we'll talk about what VUX means. So the first letter, V, is going to stand for a vertical line. The U, again, describes the slope. And the X refers to the equation of a vertical line, which has an equation where X equals some number. So let's go ahead and take a look at the homework, which is Unit 1, Worksheet 1. You'll be calculating slope and describing some graphs. Hopefully this is all review. It may have been a while since you calculated slope, but don't be afraid to go back and look at the notes, look at the formula, and then I'll talk to you guys again when we look at Unit 2, Day 2 notes. Thanks.